Okay, so here's a question. It asks us to solve for theta. And it also then asks us to draw the triangles for theta when we have theta between 0 and 360 degrees. So what I'm doing is I'm choosing this example so that you can try on the journal again. So tan A equals 1 over square root of 3. So the first thing I'm going to do is I have to figure out, I know that tan is opposite over adjacent. So that means, according to this then, my opposite is going to be 1, and my adjacent is going to be square root 3. So that's the first thing I'm going to do is I'm just going to draw a little sketch for myself rather than just the solution. So I'm going to put A here. So A opposite is 1, and that means this is adjacent square root 3. And I don't know what the hypotenuse is. So the first thing I'm going to do is I'm going to calculate that so that I can draw these triangles that they want us to do for the second part of the question. So when I do this, obviously it's just Pythagorean theorem. So I know h squared is going to be 1 squared plus square root 3 squared, which is 1 plus 3, which is 4. So I know that h is 2. The next thing I'm going to do, okay, is I know at least later on about cast as well that the two locations that this positive ratio is in is going to be where where tan is positive, which is going to be in the first quadrant and in the third quadrant. So what I'm going to do is I'm going to draw my Cartesian plane. I'm just going to switch to black. So as we already figured out, I know that I have one terminal arm here, and the other terminal arm is going to be here. Now, some of you, when you're drawing your triangles, you're actually you're going like this to make your triangle. That's not where it goes. It always goes directly to the x-axis, okay, directly to the x-axis. So that is where those two triangles are. So always never make your triangle to the y-axis, always to the x. So this is my first theta, and this obviously is going to be where my second theta is located. So now if I actually draw this, I know that my hypotenuse, according to this here, has to be 2, and it will be 2 in both cases. I know that the opposite is going to be 1, and the adjacent is going to be square root 3. The same thing is going to happen here. So my opposite is going to be, I have a 1 and a 2, but a 1 and a square root 3. But my problem is, when I'm in this quadrant, both the x and the y are negative. So that's what I have to put here. So this is a -1 and a negative square root 3. Okay, so that has my triangles drawn. Now, I don't know if you noticed here, this is one of the special triangles. So when I think of the only one that has a square root 3 in it was the one that had 60, 30. So this was that. And the way I determine then, and I'm just going to take that little bit that I drew in there so I can bring it down so you can take a closer look at it. So the way this works then is they're telling me that tan is 1 over square root 3. And we know that that's opposite over adjacent. So I want the opposite to be 1 and the adjacent to be 3. So the opposite to be 1, adjacent to be square root 3. So I know it's 30 degrees. So I know that in the first quadrant, this theta here is 30 degrees. And in the third quadrant, it's going to be 180 plus the 30, which is 210 degrees. Okay, so that is how I figure out my theta, especially if it's a special triangle. Now, if it wasn't a special triangle, I would have to use my calculator to come up with the ratio and do a tan inverse. And then, but still, I would still draw my triangles the same way. Okay, so for most of you, this part here was the real issue. Now, if you look at, there's my solution that I've highlighted in red, but look how much work we had to do to get to our solution. We had to understand that tan, just going to switch to magic pen. We had to understand that this is what tan equaled. I had to then convert that to that. We had to then do the right angle triangle, calculate this. Then I had to look, okay, where is tan? Oh, positive. Well, tan's positive in this quadrant and this quadrant. So that at least then tells me where I have to do my triangles. Okay, so you can see that there's an awful lot of work involved, even though the part that's highlighted in red is the actual formal solution.